classic stories are actually very gruesome in most cases.
But that's the whole point. You want to scare kids so that they don't do bad things. Okay? You don't scare kids when you say, you know what, it's okay to do it a few times, somebody's going to rescue you all the time. No, that's not going to work. You have to tell them, you do it once, you're dead. Look at that friend of yours. He turned into a donkey, and he got worked to death, in a horrible ending of that friend. The cricket died the first day. If you read the original story of Pinocchio, the cricket died like on page 3. Okay, Pinocchio decided, and you're nagging too much, and he threw a piece of wood to the cricket and just smashed him into pieces. That was the end of the cricket.
Hans Christian Andersen did Pinocchio, right? Was it Hans Christian Andersen that did Pinocchio?
I think so.
He also did The Little Mermaid, I think, right?
Yeah. Which
No,
Disney
no,
also
story.
butchered the story. Yeah. That's the whole point. If you don't listen to your dad, and do things that you're told, you're gonna meet a very sad ending. Nah, it'll be okay. Somebody's gonna rescue you.
I don't know. I don't really get why in our society stories always have to have happy endings. That's totally not.
Because that's what sells. You don't only watch
I don't know. I literally just picked up For Whom the Bell Tolls yesterday. Why can't we have well-rounded stories like these? It's a world of gray. There's good, there's bad, and it depends on how idealistic you are.
Or there's no good, there's no bad. Those are all labels.
Well, yeah, exactly.
Like if you watch Miyazaki's anime, a lot of times.
I love Mononoke.
Yeah, there's no good or bad. That's just it's things are just how they are.
Yeah.
Like even Laputa, they do have the bad guy, the really bad guy, but the pirates were not really bad people. They were just.
Well, even the bad guy, he was trying to, he thought that, he wanted to be the emperor of some new kingdom, but he thought bringing this technology to the world would entitle him to that position because it benefited the world.
He wanted to resurrect the kingdom.
Yeah.
Right, because he thought, hey, there's no reason why we cannot rule the world with all this technology and whatnot.
Yeah.
Yep. So.
First for
Yep.
class, on the exam, dropped question 5 and kept question 4.
No, that's not what I did. I changed the grading scheme so that it would drop the lowest score, whichever one is the lowest score, it will drop it, and then one of the questions becomes extra credit, but it should not be designated like which one.
Okay, mine dropped a 50% of the question and kept a 0.
Really? Okay.
Yeah.
Send an email to me so I can adjust Moodle so it doesn't.
Okay.
So it would do what I intend to do.
All right.
That was not my intention. Okay. All right. So what we'll do today is we'll go ahead and I'll show you the solution of the homework assignment that is due today. Okay. I got several questions from email, not a whole lot. Okay, but yes, you send me email. Okay. And then we'll talk about the new homework assignment, because the new homework assignment is what is going to connect the new concepts to some of the older concepts. Okay. All right. So we'll get started with the old homework assignment first, the one that that was due today. It's called more division. Okay. So we'll take a look at more division. So here's more division. Let me just zoom in a little bit, so this way we can read a little bit better. Okay. I'll do exactly the same thing that you have to do. So we'll save the file into the downloads folder and open up a terminal and work on it. Is this font size okay? Okay, sure. All right, so we'll go to the downloads folder, take a look here, and it's called more division.
You're recording, right?
I believe so. Let me double check. Yep, it is recording. All right, so this is the program that you're supposed to work on, that is due today. Write your code here. It may not contain the following, okay? No do, no while, no for, no go to, which means you cannot loop within the subroutine itself. It may contain the following constructs, which means, okay, you might want to look into these. Subroutine calls to divide, okay, because it is recursive. Expression statements, okay, because you need expression statements to change something. Okay, and also conditional statements. Okay, so you might need to use ifs. Okay, so those are the what you can do, and then we'll go ahead and talk about okay, how do we get started with this homework assignment? Okay, when you start with a homework assignment, the first thing you need to do is not to start writing C or C++ code right away. The first thing you need to do is to analyze what the program or what the subroutine is supposed to do in this case, and then figure out the logic first. Okay. Now the next question is, well, okay, let's just say that I figure out the logic, but how can I test that logic without C++? If I don't write the program in C or C++, how am I going to test the code? Okay, do you guys have any questions? No? Okay, go ahead.
Okay, so I completely have no idea how to get over the fact that X and Y are not initialized and have divided being 0.
Okay, one of them, okay, X and Y are both uninitialized. That is correct. So the quotient and the remainder are both uninitialized. So now the question is, yep.
Sorry, I didn't mean to cut you off.
Yeah.
Oh, are you gonna dock us if I made my code unbreakable from putting the divisor and dividend at 0?
Yeah, go ahead.
What I did to do that, in the set bars here, I set the variables before they went into the.
Do they have to be set?
Huh?
Do X and Y have to be set before getting into the subroutine? If I leave them uninitialized, will your code continue to work correctly?
I'm not sure, but when I debugged with wall, it said uninitialized variables, but my code was junk when I first did it, so I don't know if it was part of my junk.
I cannot really talk about it now because I really need to read the code first before I can make a call.
So you couldn't tell me right away if you would dock me for setting values to the X and Y.
You should not need to.
But would you dock?
Yeah, main should not be touched. So you should leave main the way it is. And only your code, see right here, write your code here. That's kind of saying, okay, that's the only place where you can put your own code. Okay. All right. So now the question is, how are we going to work on this one? Okay. With recursion, what is the most important thing that you have to think about first? The one thing. Sorry?
First in, last out.
First in, last out. Last in, first out, LIFO. Okay, so that's one. Okay, but what is the other thing that you have to think about with recursion? If you read all the examples that we have up to this point with recursion, factorial, and all the other programs that we have done so far with recursion, what is the one thing that is common amongst all of them? Yep.
The dividend should always be greater than
Say it again.
dividend greater than divided so that
Okay, a condition. Okay, very good. Okay, so I heard the word condition, which is good. Okay, so we have to think about a condition. What condition are we talking about? Why is it important? We're talking about recursion. What is recursion again?
Recursion is basically a loop in the subroutine.
It's not a loop, okay, but it is. It does something. It calls itself. Very good. Okay, so if you do not have any condition, okay, and you keep calling yourself, then it's not gonna end.
Forever.
It will do it forever. It will use up the entire stack, and you will end up with I'm pretty sure somewhere if you encountered the problem, you end up with a segmentation fault, right?
No, I didn't.
You did not? Okay. Okay, but that's the first thing you have to think about is a condition, okay? When do I stop? Does that make any sense? Okay, so we'll work on that first. So what you need to do is to think about when do I stop. So you basically say if blah, blah, blah. Oops. Wrong curly brace here. So we know for certain. Okay, do you guys have any questions? No?
I mean, you're getting to it.
Okay.
I just looked at it and I don't know why. Like, I kind of figure it out how to like initialize quotient before like getting into the subroutine. And he showed it to me, and I'm just like, wow.
Okay. Okay, so you figured it out.
I'm kind of
Okay.
bad, is all.
I figured it out too late.
Too late.
Yeah, it was like I was sitting
Okay.
there like beating my head up against the wall, and then all of a sudden someone just comes up and it's like, oh, it's this. You just equal to 0, and then I'm like,
Yeah.
cool.
Yep, that's right. Yep, go ahead.
So, quick question. If you have functional code, that would work with the exception of initializing code for remainder. So just the complete knowledge of which one.
Well, you will still get partial credit, okay? But it's not self-contained. The subroutine is supposed to be self-contained. You do not need to initialize from the outside.
I guess my comment that, I guess, because I don't know if this will pass the script on mine, because it would if the initialized values would the same across two different brackets.
It probably will not, because if you need initialization from the outside and the script is calling the subroutines without reinitializing stuff, then your program most likely will not work the way it's supposed to. Except for the first one. The first time it runs, it will still work correctly, and then the second run, it may not do it correctly. Yep, go ahead.
How many points on this?
Say again?
How many points?
How many points? I think this is a 30-point homework assignment, if I remember correctly. But that will continue to go up to close to 100 points per homework assignment. So, so the stake keeps increasing. Okay, the stake is going to go up. All right, but getting back to the program. Okay, this is the most important point. Is how do we get started with this homework assignment? How do you think about it? Okay, so we need a conditional statement, and it's up to you to decide which part is doing the recursive and which one is not doing the recursive. Okay, it's up to you. Yep, go ahead.
Oh no, that was a question.
Okay, so I'll just say that this is the part where we need to do recursion, and this is the part that we do not do recursion. Okay.
Yeah, I would do that like a pre-check for a loop almost.
Okay. All right. So I need a condition to tell me whether I have to call the subroutine or not. Okay. And what do you think that condition is going to be?
If dividend is greater than or equal to divisor.
Okay. If dividend is greater than or equal to divisor, I need to do recursion. That is absolutely correct. Okay, because if dividend is less than divisor, I don't need to do anything anymore. Okay, because I know right then that the remainder is going to be just the dividend, and I also know the quotient is going to be 0. Okay, so we can actually initialize quotient inside the subroutine. It does not need to be happening outside of the subroutine. So we'll handle the easier case first. Okay, no recursion. If there's no recursion, which means the dividend is less than the divisor, then the remainder is just going to get whatever the dividend is. And on top of that, we also know what quotient is, because quotient is just going to be 0. Is that making any sense?
Yeah, that makes sense.
Okay, but that's how I would think. That's how I would process this when I need to do divide using a recursive mechanism. Okay.
What was confusing?
Sorry.
Was confusing actually.
Which part is confusing?
Was the initialize quotient?
Okay. What are you confusing it with?
Yeah, to initialize, that's the way I was almost close. I didn't initialize the quotient. I didn't initialize my quotient equal to 0 when thereby remainder equal to dividend.
But this is the case where you have the answer right away. When your dividend is less than divisor, you have the answer right away, and at that time you can say, okay, if the dividend is less than the divisor, I know right away the answer is quotient is a 0, and the remainder is whatever the dividend is. Is that okay or not?
Yeah, it is.
Yep.
When did you say that you won't be making a dividend of 0? Did you say that verbally? It wasn't in the instructions.
Well, it's always going to be, if dividend's 0, then the quotient is always going to be 0, because you can't divide 0 by anything.
Right. But if dividend and divisor both equal 0, that code won't work.
That is correct.
So if I are you going to penalize me for? Would you penalize someone for testing for every?
No, as
No.
long as your code works with my test cases,
Yes.
and it still follows the same rules, it's not going to get penalized.
Okay, because the only thing I did was write initialized variables in the main program. But if you did just the test cases, everything will work. So
I'll show you guys how I'm going to test this, okay? But because there is still this statement here to say write your code here, which means your code cannot be sprinkled into the main subroutine. Okay, so that you still have to do it. You still have to put all your code inside divide. Okay, so when in the case that we do need division, what does it mean? Okay, we have dividend being greater than or equal to divisor. So what I know at this point, okay, is, oh, I know that the quotient is going to be at least 1. But I don't know how much more than 1. Is that making any sense? Because I got, I have more candies than there are kids that I need to distribute with, okay? So the only conclusion I can have at this point is, okay, every kid gets to have at least 1 candy. But exactly how many candies? I don't know, but I'm in charge of only giving 1 candy to each kid. Whatever I have left, I'll leave it to somebody else to distribute to the same number of kids. That is the whole idea of recursion, is you break the problem up into smaller chunks, and then you call the subroutine again, but this time you process a smaller problem compared to what you start off with. Is that making any sense? Kind of? Okay? So the code to do this is basically to say, okay, I'm going to call divide first. So I will call divide, but dividend is not going to be dividend anymore. It's going to be divisor, I have to subtract divisor from dividend first because I am taking care of divisor many candies, distributing that much to the kids. So the next person does not need to handle the original number of candies, but the original number of candies minus the divisor, which is what I'm going to distribute to the kids. Does that make any sense?
The way you're saying it doesn't. It kind of does.
Okay, so let me finish this first, and then you guys can tell me which part of it does not make any sense. Okay, quotient is still quotient, remainder is still remainder. Okay, so let's take a look at this line. Yep.
Couldn't you do a difference assignment operator instead of just a difference operator? Yeah, minus equals 2.
You can, but it's not necessary. I'm not going to take any points off if you do it minus equal to, but it is not needed. You don't need to actually change dividend
Yeah, because
as
you
a
have
parameter.
remainder as a variable. I understand that.
Correct.
Just made it easier to type.
Okay. Yeah, but you can use minus equal to, but there's no reason why you have to change it. Okay, so once we have this done, by the time it comes back, what do I have? When it comes back, I will have the quotient and the remainder of this value, which is dividend minus divisor, divided by divisor. I will have the answer to that question. Okay? But that's a sub-question. Okay? That's not the question that was posed to me. The question posed to me is not what is the quotient and remainder of dividend minus divisor. The question that I have the answer is what is dividend divided by divisor. But if I know the answer to this question, don't I know the answer to my own question? No? Yes?
Eventually.
Okay, so I will give you an analogy, okay? So let's just say that, I was given 45 candies, and I have to evenly distribute it to 20 kids.
Yeah.
Okay, so there are 20 people, and I have 45 candies. I pass the problem on to another person, and I ask the next person to go like, hey, I'll give you 25 candies, and there are 20 kids. I'll let you figure out, how many candies you can distribute to each kid, and what is the remaining number of candies. Okay, what do I get back as the remainder of the candy? And I'll leave it up to you to do your processing, okay? So when you're done, you come back to me and say, okay, well, with 25 candies, I can distribute 1 candy to each kid, and we have 5 left. That's your answer back to me. Now, that's not what I had to answer, right? Because my problem was I have 45 candies and 20 kids. But since I know that with 25 kids, you can only distribute 1 candy per kid and you have 5 left, and my number is only 20 more than your number, so I can just say, okay, now I can distribute one more candy per kid, but I will keep the remainder.
Yeah.
Right? So that's why the next statement here is just to change the quotient itself to 1 more than what it used to be. And that really is the answer. This is the entire thing. Yep.
So, for example, if your dividend is 3 and you divide it to 2, wouldn't it become like 1, 2, and you'll go into else instead of just 0 again because your quotient equals 0 right there?
Say that again?
So once you get out the recursion, right? Because
Yeah.
you said 3 and 2,
I pass one to you, and you come back. Oh, it's not enough, right?
Yeah.
And you come back to me, but then the main dividend, and then it runs through the function again. Wouldn't it go into else and set quotient to 0?
But once you get through, then it's not going to go to else. Because you only take one of the branches. You cannot take one branch and then take the other branch. With a conditional statement, it is just, you have to take one and only one branch.
What
If
he's
you have
saying is
decided, yep.
Once you get to else, since else is the defining where you get out of the subroutine, right?
Yes,
When a quotient equals 0, because you initialized it as 0 in that spot, then you would come back.
Yeah, you come back to 0.
Then it goes back to the previous invocation. Okay, I can kind of see where the confusion is because you guys are forgetting that we have multiple invocations, and then each invocation has its own spot to get back to continue execution. Okay, so I think a GDB session is called for, okay, because that's how you can actually see how this works. Okay, all right, so let's go ahead and do a GDB session. In fact, we'll go ahead and see. Do you guys want to keep this as the problem? 65 divided by 12. Yep.
I also got a problem with the remainder equals the dividend. What if the remainder is smaller than the dividend?
What if the remainder is smaller than the dividend? But remainder is uninitialized up to that point.
Oh wait, you're doing remainder and dividend. I thought you were going to do divisor. Never mind.
Okay. All right. So let's go ahead and just make this run. Because there is. Yep. Go ahead.
Can you change either to 65 or to 12 so it's not 5 and 5?
Oh, okay. I see. We can make this 66.
Okay.
Okay. So now we have 5 as a quotient and 6 as a remainder. Okay. So let's go ahead and do a G++ dash G dash C, and we'll turn on warn all too, just to see what kind of warning we'll get back here. Okay, set var, so it complains about the labels because I don't have any go-to statements to make use of the labels. That's okay. The only reason why I have labels here is for my debug script to work so I can grade this semi-automatically. And now we can link the program G++-O, which is the link command, and the input is main.o, and then now we can do a GDB main. All right. So we can stop at a few places. Okay, what my script is going to do is to put a breakpoint on line 28, but the way I do it is main : set vars here, and it will also set a breakpoint at stop here. So main : stop here. We'll get another breakpoint. Yep.
When you use the list command, why did it start at 15 and not 1?
Say again?
When you use the list command, why did it start at 15 and not 1?
Because it starts a certain number of lines before the entry point of the entire program. Okay, so let's go ahead and run the program. So at this point, it's ready to call the subroutine. The way I test your subroutine is really just to call it from GDB itself, which I have to figure out because I don't know whether this will work. So let's give it a try. Okay. Yep, it does. So now I can print X, I can print Y, and that's how I'm going to test your program. Okay, but it does work, but it doesn't show you how it works. So what do we do to really get an idea of, okay, but how does this code work? It just doesn't seem like it's supposed to work here. So what we'll do is we'll set a breakpoint in divide itself. You can actually set a breakpoint based on the name of a subroutine. What this does is every time you get into the subroutine, every single time divide is called, it will stop. Okay, which I think is going to be helpful. So we'll put a breakpoint here, and then what I'll do is I'll just continue execution because we are still on line 29 right now. Okay, so we can just do a continue to continue the execution. Yep.
You set another breakpoint for after divide has been called so we can check the quotient or everything, or are you just going to single step?
Okay, but you have to specify where after divide is called.
Like write it after you implement it.
Inside divide itself?
Yeah.
If we single step, we'll still be able to get to that point. Okay. So now we continue execution. Okay, so now this is important. Okay, this is important. This is the first call to divide. The first call to divide has 66 being the dividend and 12 being the divisor. Does that make any sense to you?
Yeah.
Should, right?
Yeah.
Okay. Now, what we have in quotient and remainder should not even matter because that can be uninitialized at this point. Is that okay? All right. So now that we are in the first invocation, we are about to execute line 10, which is based on the comparison of dividend versus divisor. So which branch do you think we are going to go for? Are we going for the then branch or are we going for the else branch?
We're going to the then branch.
The then branch, because dividend is clearly greater than or equal to divisor. So single step, we'll get onto line 12, line 13. On line 13, it is calling the subroutine again. Okay, so when we single step this one, we'll see that A, it's about the same as the first time because we see that we are calling divide. Okay, this is the call itself. This is the first invocation. This is the second invocation, which seems to be exactly the same, but you can see that something is different. What is different between these two invocations? One of the parameter has changed. The dividend has changed, right? The dividend is now divisor less than what it used to be, okay? Which is what the code is supposed to do, okay? So when we single step again, it will go to line 13 again. Single step again, it will do another recursion. And now we're comparing 42 to 12, single step, 30 to 12, 18 to 12, and finally we have 6 and 12. Okay, so now the question is, how many invocations do we have at this point? Now, if you are squinting and you're trying to count, it doesn't matter what the number is, you're doing it correctly. If you think there's only one invocation, that means you're not understanding that we can have multiple invocations at the same time. This is a really critical moment. If you are squinting because you're trying to count the number of invocations at this point, you are understanding the concept correctly. Because you're definitely saying, okay, there are multiple invocations at the same time, and I just need to count how many there are. Okay? On the other hand, if you're not counting and thinking, oh, that's only one invocation, this is the only invocation in the system, then you need to kind of adjust that understanding of invocation. One thing we can do is BT. What do you think BT is going to show us? You don't have to know exactly the number of things that it will show us, but just a general idea. What do you think BT is going to show us? A number of invocations, right? Okay. The last invocation is going to have 6 as dividend. The previous one 18. The previous one 32, 42, 54, and eventually 66.
Yeah.
And then main as the last one, because main is the starting point of everything. Exactly. So let's do that. Let's do a BT, and that's exactly what we're seeing. Okay. I'm going to try to make this as wide as possible, so this way, there's less wrapping around. Well, it doesn't really help. It needs to be even much wider than this. But you can definitely see, how we have invocations upon invocations. This is where everything starts. Number 6 is in main. This is the entry point of the entire program. The first invocation to divide has dividend being 66. Then I subtracted call again, so now it's 54. Subtracted, not 6 but 12. So the next one has 54, then 42, 30, 18, and eventually becomes 6 because 18 minus 12 is 6. Yep, go ahead.
How come your quotient never changes and your remainder never changes?
That's a good question because those are passed by reference. And when you have a pass by reference parameter and you're passing it on by reference again, what is the result of that? What are you passing? Are you going to pass a reference to a reference, or are you just going to pass the reference itself along to the next invocation? Yes, exactly. And that is why when you look at quotient, it is the same address all the time because you're passing the same call number to the same book to the next invocation. Because every step along the way, you just want the next invocation to have a way to find the original item. So the way to find the original item has not changed. It's just, so you're just passing that along. Okay, let me see if I can answer your question first. Go ahead.
So I'm still confused. I got quotient to started, at least when mine was initialized, it just starts out as one.
You don't need to initialize. quotient and the quotient and the remainder do not need to be initialized.
Okay, then you might just get mine, because whenever I ran it through the process of mine, at the end I just ended up with whatever random number got from that, and then it would be subtracted by the amount that was added to the quotient. Or at least that would be added to it, I should say.
Okay. All right. Let me see if those guys have any questions. Do you guys have any questions?
No,
Nope.
not anymore.
Not anymore? Okay. All right. So I'm going to do one thing that will change BT completely, okay? What I'm going to do is to change variable x and variable y of main at this point, okay? The question is two-folded. One is how am I going to do it? And two, is it going to change anything in this code? Will it give me the wrong result if I were to change x and y at this point? Well, okay, first question, let me answer the first question. How do we change local variables x and y at this point? I am very deep into, let me count, okay, the sixth invocation of divide at this point. And main is all the way out. Which command in GDB do I use to go back to a previous frame and say, I want to change this now? We talked about that, okay? Starts with an F. Frame. Okay, we use frame to go back to any frame that is active at this point. So we want to go to frame 6, okay, because it's 6 frames ago. Okay, we go to frame 6. So we are now back into main. Now we can say set var x equals to some gibberish, set var y equals to some other gibberish, make it a really big negative number. Okay, then I do BT again. What do you think I'm going to see this time?
You're going to see quotient 5 and remainder 6.
Nope.
No? I don't know what will happen.
Okay, let's find out. Okay, this is going to be fun. What do you see as a quotient and what do you see as remainder? The gibberish that I just entered. Why? The question is why?
Because as soon as you get out of divide, it changes the variable.
Because remainder and quotient, they are parameters passed by what again? Reference. And they are references referring to what?
Some random place in memory.
Not random. How did I specify those two parameters in the first call, the very first call to divide? What did I use to specify quotient and remainder?
X and Y.
X and Y. Okay, so that means they are references to local variables x and y in main. Does that make any sense? Sort of? They are parameters passed by reference. So the next question is, what are they referring to? The first time I call divide from main, I use local variable x to specify quotient. I use variable y to specify remainder. Right?
Yeah.
So that means parameter quotient is a reference to x and parameter remainder is a reference to y. And that's why when I go back in time and change local variable x and local variable y in main, all of these parameters, quote unquote, has changed. They really have not changed a single bit. They are still referring to the same location in memory. It's just that I have changed the content at that memory location. Are there any questions about that statement?
How is that useful?
How is that useful?
Yeah, I don't really.
This is why, okay, but this is why we do not need to initialize from the outside. Yep, go ahead.
Okay, so I guess just where the gap in my knowledge is here, because what happened to mine was it starts off in main, int and x are uninitialized, so they have case of x for me, it was just a giant negative number. Then moves into divide, it goes through. And then after I checked the value of x, after it had passed through all the necessary frames, it was just that number. Then, in the case of the original settings,
You don't need that. See, you don't need that at all. Okay, let's go back to frame 0. Okay, so let's go back to frame 0. We are about to execute line 10. Okay, so now the question is, based on what we see as dividend and what we see as divisor, Are we going to the then branch or the else branch? The else branch, right? Okay, so let's single step. We are clearly going to the else branch. So when we get to the else branch, what is this statement going to do? What is line 19 going to do? It seems like a very easy assignment statement, but in the context of recursion and passing by reference, this is going to do something that is a little bit more than what we usually expect. Okay? Sorry?
It's going to set y equals dividend.
It's going to set y to whatever dividend is in this invocation. Okay? So what is the value of dividend in this invocation, in the current invocation? 6. Okay? So the right-hand side of the assignment has a value of 6. Where are we storing that into? We are storing that into quote-unquote parameter remainder. But as a pass by reference parameter, it does not actually have a way to store anything. All it is a reference to another place. Where is it referring to?
Back to main.
Back to local variable y of main. So line 19, the way it is right now, is going to change local variable y of main to 6. Are we still doing okay so far with that concept? Yes? Okay. Okay, so let me just single step first. Okay, so what I'll do is I'm going to print remainder first. Okay, it is some sort of gibberish because I said var earlier to this gibberish. We print dividend. It should be 6 right now. It is. So I single step. Okay, and after single stepping, and I look at remainder. Okay, remainder is 6, which is not surprising. This is not the surprising part. But if I do a BT, then you will start to see something that is like, oh, why? Because when you do a BT or backtrace, you will see that every single remainder, parameter remainder, has a value of 6. Now this one is not surprising because this is the invocation that we're in at this point. But what about this one, the previous one? This remainder has a value of 6. This remainder has a value of 6. This remainder has a value of 6. They all have a value of 6 because they all refer to the same location. They're all aliases of variable y of main. That is why when you change a parameter that is passed by reference, everything else that is also referring to the same location would quote unquote get the same value. Is that part okay?
Yeah.
But does this mean that if I go to the main frame and I look at local variable y, that should also be 6?
Yes.
Okay, let's double check, okay? Because we want to go through as many commands as possible just to confirm that. So we go back to frame 6, which is 6 frames ago in main, and we say, okay, what is local variable y of main? Printed, it is in fact 6. So that means all these parameters, okay, since they are all passed by reference and they're all referring to the same thing, when we change what they refer to, whatever they refer to is changed. Is that part okay? This is why you do not need a initialization outside of the subroutine. Because inside the subroutine, if you do this at the very tail end of the recursion, then when you backtrack, when you go back to the previous invocations, they can make use of the initialized values of quotient. And they just need to add 1 each time to get to the right value.
Yeah, maybe I'm just confused on the way that basically, like, when the recursion happens and you call the subroutine inside itself, what is like the order in which comes after? Like, how does it, like, if it calls itself, does the code that happens after the call, the invocation, that goes through also?
Well, let's take a look, because we are now at the very end of the recursion, and we are going to unwrap things, okay? Because if you look at this as, I don't know the name of those Russian dolls, one inside the other one, okay? We are now at the innermost one, okay?
Yeah.
So we are going to unravel things at this point, okay? Or I should put it the other way. This is the outermost, okay, because it's inside out in this case. So we are now going to unwrap the outer one to get to the inner one, and unwrap that one to get to the inner one, okay?
Sure.
Okay? Okay, so this is the last invocation. So let's go back to the frame first so that we can continue execution. So we go back to frame 0, which is the current frame, and we're going to execute quotient equals to 0. Now, if I do a VT, I think this time it is not surprising at all that all quotients get to 0 because they are all referring to local variable x of main. Is that okay so far? So when you have a parameter that is passed by reference, they do not have a value on their own. All they do is to say, well, I don't have a value, but over there, that's the value that you want to get to. They're all aliases. Okay, they're all alias of something else. Okay, so let's single step because we are now about to end the last invocation, which will go back to the previous invocation, go back to invocation or frame 1 in this at this point. So when we get back to frame 1, where am I going to continue execution? That is the question. Okay, if you look at frame 0, this is frame 0, this is we are about to end because we are on line 22 in frame 0. When we return to the previous frame, which is frame 1, where am I going back to? And the answer is here. It's actually just 2 lines below where I have highlighted. Where am I going back to? Which line am I going back to?
Which line are you going back to?
Yes. It's spelling out because it tells you where I came from. That's where I go back to.
It's 13.
13 is the correct answer. Okay, so when invocation 0 is done, when the current invocation is done, it's going back to the previous invocation. But where was I in the previous invocation? Line 13. Okay, the line 13 is not very exciting because if you print line 13,
Yeah,
okay.
print out line 13.
Okay, so we'll do a line 13. Line 13 is the call to divide. So it's going to go back to this point.
And then do everything afterwards.
Exactly. Then
But
it
it
will,
does it that many times? That's the confusing thing, is I didn't think it would do it that many times.
but it does. Yep.
That's so confusing to like think about. It's not natural.
Nothing about computer science is natural because it's a made-up science. It is not a science at all. The whole term of computer science is a misnomer. It's a wrong word of computer science. Computer science
There is no
more
science. It's just whatever the last person made up. That's what you're saying.
basically because yeah, because it really is mathematics. If you think about it, it's the same as mathematics. Okay,
Yeah.
why is addition commutative? Who made up that rule?
It just is. It just happened.
Okay, it's the same thing with computer science. Okay, we made up all these rules. Okay, but for good reasons. Okay, because down the line, this capability of C and C++ is going to be very useful. You may not see it now, but down the road you will see. Okay, all of these concepts are important. They're very important concepts.
So, about how many points would you knock off if we had to initialize it in main? Because
I
I was sitting there just like festering, just like, what the hell is going on?
Yeah, well, but that's good because you spend the time to think about it, even though you did not quite get the 100% of it. That
good for my
primed
health
your
pattern.
brain. Well, that primed your brain to understand it now. How about now? Do you understand it now?
I mean, I'll remember that now, but I don't think that the way
Okay,
that it works, I
Yep.
feel like there should be like a step-by-step kind of like it does this and then it does this kind of thing. I don't know. Like I said, it's just not natural.
Yep, go ahead.
Okay, so I'm reading this right. So say you had quotients assigning to 1 plus quotient, basically, in front of the recursive call. Is that gonna
That will not work.
Yep. Okay.
That would not work because then the last invocation will zero everything. Then you only have a 0 all the way back out. So you have to do the add one after the recursive call. That's a very good question. Okay, I'm really glad that you guys are asking those questions because you are basically understanding the whole concept now. Go like, oh, so if we change the order of the recursive call and the adding one to quotient, it's not going to work. but it's not going to work in a weird way because it seems to work, and then at the very end it will initialize quotient to 0, and it just go back all the way out with quotient being 0.
I'm kind of mad that things aren't already initialized to 0. Like, what the hell? Like, come on, guys.
But it is initialized now.
No.
The last invocation is the one that initializes it. And then all the other invocations, all they do is to add 1 to it. Each level is just adding 1 to it. Yep.
No question. When you said that the dividend won't be 0, did you just verbally say that in your lecture? Because it wasn't written down anywhere.
The dividend?
Yeah, you never. I wish that in the future homeworks, you'll tell us. Oh, you will put a 0 as a divisor.
The dividend can be 0. It's the divisor that I won't make it 0.
Oh.
I mean, these are test cases that I gave you guys. So, I'm assuming that some people would take this and go like, well, I better test my program based on these test cases. Yep.
Technical question in it though, this is kind of vaguely related, but with uninitialized variables across systems, I'm assuming they differ between systems, but will it call the same one each time it runs the program, or is it also the spot times?
Okay, I'm not quite understanding the question itself. Can you ask again?
Okay, say a program on my computer that just has 2 initialized variables, and then stores whatever numbers it knows, and then I ship that program over to someone else, and they do it. I'm assuming it'll be a different random number.
If the variables are uninitialized, okay, then the initial value or the start value of those variables can be anything. So you should not make any assumptions about the values of uninitialized variables. Not in C and C++. In many other languages, you can make certain assumptions. Like most scripting languages will say they start with a certain nil or null or 0 value. But in C and C++, there's no specific value for variables. When they start to exist, they just go like, I have some random value. Okay. Well, of course it is mean, because C and C++ were never intended as a instructional programming language. Okay, think of this as a carpentry class. Okay, you guys are learning how to make simple objects in wood. Okay, and here I am with a industrial strength circular saw with no safety feature whatsoever, no guard, no safety feature, and go have at it. Make whatever you want. And I will count the number of fingers before the class, and I'll count again after the class, just so that I know how many fingers were lost in each class. That's basically what C and C++ really is. It is not an easy programming language. It is not intended as such. Of course, there are questions now, like, but why do we use it in this class? This is, like the first programming class, why do we use it in C++?
Programs won't take your fingers off, so that's one point you can make. But,
yeah, but the wrong code will send a Mars probe to,
I swear.
to the wrong planet. Okay, but is this okay? Getting back to the context of this program, are we doing okay? Are we doing better now?
Yeah, I mean, everything about the program was fine. It was just the initialization, and like I was thinking of the problem. I was just like, all right, how do I initialize quotient at 0 without it initializing itself? So with so many invocations,
Yep.
And like you just did it in 2 seconds, and I'm really disappointed.
Well, that's okay. I got I got a few decades of experience under my belt. So
is what's going on.
But this makes you think though. I mean, this homework assignment, all homework assignments are supposed to stump you a little bit, make you think. Even if you don't get 100% of what the solution is supposed to be, it starts you thinking. Okay. So when I disclose the solution, then you absorb the material like, okay, I guess that's how you do it. Okay, as opposed to not having the homework assignment and just tell you, oh, this is recursion, this is how we call, this is passing by reference, and then the moment you walk out of the classroom, all that stuff is gone, right? Yep, go ahead.
Mm-hmm. No, I'm okay.
Okay. Okay, but I do want to, I know this is kind of out of the context of this class, but I do want to share with you, the history of C and C++, just so that you know what you're dealing with, what kind of circular saw without safety that you're dealing with, okay, because that's basically what it is. Okay, so I think I showed you this guy already. His name is, gosh, I cannot remember his name. Yeah, Richie, I'll just type these two and I'll find it. Dennis Ritchie, that's it. Okay, Dennis Ritchie. All right. Do you remember I showed you this guy like a long time ago? Sort of? Okay, so who is he?
He's the guy who created C.
He's the guy, but C is a byproduct. He did not even set out to create the C programming language. That was a byproduct. What is the main product, or what is the main project itself? What is the motivation that he actually created the C programming language? He was trying to make Unix, exactly. Okay, so he was trying to make Unix, which is an operating system, this one here, okay? And if you have not written an operating system before, I'm pretty sure most of you have not, because if you had, you would not be here, okay? Okay, an operating system is a complex piece of software, okay? That's the least you can say about it. It's a complex piece of software. Extremely difficult to debug, okay? Because you don't have a platform to debug it with, okay? So you're basically building a platform where everything else would sit on, okay? So this is difficult. And he's trying to write the entire thing in assembly language, which is equivalent to making a castle out of individual grains of sand. So you can kind of imagine that he got bored, after a while. It is not efficient. So he said, okay, can I make a tool to make programming a little bit quicker? That turned out to be C, and then later on it became C++.
So did he make C before Unix, or did he make Unix?
Along the way. He started off with the Unix project, and after I guess a few months,
So before
he got
Unix was
tired.
created, he finished C.
Before Unix was finished, he finished C first.
Okay.
Because C was a tool. Basically, he was asked to build a house, a big structure
So
in
did
wood.
he basically program Unix with C?
Yes.
Okay.
Well, the majority. Unix has to be programmed partially in assembly language at the lowest level, but
Yeah.
for the most part, you can actually do it in C. So that's what it is, okay? So he did not write this. He did not create the C programming language as an instructional programming language. He did not write. He did not create it for commercial or business applications. He did not intend it for anyone other than himself. And what do you think is his level of expertise in programming?
Arbitrary levels?
Yeah, he's like way up there in the clouds. Okay. Okay. And this is the tool that he created for himself. So do you think he would think about, I think this is going to cause confusion, if we use this programming language as the programming language of the very first class in computer science? Do you think that crossed his mind at all? Absolutely not.
I must have thought that he could never go senile then. Messed up.
Well, the guy lived a fairly long time. He lived up to, well, I guess it's not too long, 70. But his contribution is actually very significant in computer science.
Yeah.
But I want to show this again, not because it is related to C and C++, the programming language itself, as far as what you need to take out of this class, but I need you to understand that C and C++ are not easy programming languages to learn. Okay? Now, I can teach this class in an easy way and not talk about recursion, not talk about recursion and passing by reference like what this homework assignment is about. That I can do, okay? But is it going to help you? The answer is absolutely not. It will only hinder you later on because you did not really quite get the concept of recursion. So that's why I want to make sure that you guys get the concept in this class. Yep. Alrighty. So are we doing okay so far with this code? Do you guys want to finish the trace or just kind of leave it the way it is?
You pretty much went over it all. The only question I have is is, do you have to have a return statement since it is void? Like,
You
I
do
put
not.
a return statement just to be formal. You know?
You can do a return, but since you cannot
You don't
return
put
a
anything in the
value,
return, you just put
Right.
a semicolon.
yeah, exactly.
But it would, for like later assignments, would that be like a requirement? Kind of
No,
thing?
the convention is with void functions or functions that return void, you do not use a return statement.
Okay.
Yep.
Because I just, for my, it helps me in my brain to be like, all right, this is where subroutine ends. Like, there's no more after this.
That is correct. But if you put a return inside a branch of a conditional statement, that is when things turn a little gray, because that return will trigger the subroutine to actually return, even if you have code after the return statement. So that can cause confusion.
That could be helpful though.
No, it is never helpful.
It's never helpful.
Now this is this is something that certain professors will argue with me. Whether we can have return inside a branch inside a subroutine, but in general, that's not a good idea.
Because wouldn't it like eliminate like conditional statements, like having to write like long conditional statements
Okay,
and
so
like exits for conditional statements kind of thing?
okay, so let me kind of put it here so I can demonstrate what I mean by that. So you're basically saying, okay, if we put some extra stuff here, it is okay. Now, these two returns do not change the meaning of this program at all, right? Because they are placed where it really is the last thing the invocation has to do. Okay, so putting returns here do not really make any changes. However, if later on I have something else to print here, okay, so let's say later on I want to print divisor or quotient, okay, so if I want to track quotient along each invocation, this is the wrong syntax, but that's what I intend to do, okay.
Yeah.
This will never be executed because with either branch, the last statement is return. So upon the execution of a return statement in C and C++, it will actually terminate this invocation. So even if you have additional statements after the return, all of those statements will never get to execute. And that's why, personally, I do not like putting returns inside a branch of a conditional statement, inside a loop or anything like that. I would always, just count on getting out of the conditional statement, getting out of the loop, getting all the way to the end of a subroutine to actually terminate the execution of a subroutine. Yep.
Can you use break to do a similar thing without having it actually exit out?
Yes, but break is not a good idea either. Anything that can break the normal flow of logic other than the condition of a conditional statement or the condition of a loop, to me, is not a good idea.
Okay.
It makes the analysis of your code harder. It also makes finding bugs harder too. Because now you have multiple ways to get out. When you're out of a loop, how did you get out? Did you get out because the condition is false, or did you get out because of a break statement somewhere in the loop itself? That becomes the question.
If you wanted to turn in a functional not of an assignment.
Alrighty. So are we doing okay so far with this homework assignment? Sort of? Okay, so if you think I'm getting about 75% of the concept, but the other 25% is still kind of cloudy, I would suggest watching the video again. But because when you're watching the video, you are free to pause. Okay, when you're in a class, I really cannot let people pause me too often because otherwise the class is not going to go anywhere. But when you watch the video, you can pause. But when you pause, you're not going to. You don't want to watch the video and try to memorize what I said. That's not the intention of recording the video. You need to understand what I mean when I said blah, 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 okay? And the demonstration using GDB is one way to visualize, to actually get to see the execution of the program. Because I could have described this in a dry way, just talk about it all day long, but that's not going to be helpful. GDB helps you understand the concepts because you can actually get to see the different frames. When you continue execution and single step, you get to see where it goes to continue execution. That is why GDB is so important in this class. Yep.
When are you going to post the video for Monday? Are you going to do that over the weekend?
The one on Monday, I think oh, that's right. I got the video and the audio recorded separately. Is that the day? Yeah, I think so.
It's last Monday, whatever it was.
Okay. Just, can you send me a reminder to upload
For
it?
sure, yeah. Because I couldn't come in that day, so. I need
Okay.
to go.
Ah.
If it's relevant to the next assignment. I mean, if it's irrelevant.
Now the next homework assignment is here, so we'll take a look at the next one. Okay, so let's take a look at the next homework assignment. I only got about 15 minutes to describe it, so I probably will have to defer the due date of the next homework assignment because it has to do with input and output. Okay, it's about budget. Okay, this is a new homework assignment. I have never used this one before. Okay, so here's the next homework assignment. You're supposed to use a function called scanf, which we have not talked about yet in this class. So I'll see how far I can go today. But most likely I will have to give you guys another 5 days or so to work on this one. So you have to use scanf as a function to write a program. So it will read a base 10 signed integer, which means the integer can be positive or negative, as the initial balance. Okay, so this is how much money you start off with. And then you have to read consecutive base 10 numbers or integers as expenses. So you don't have to worry about decimal points and stuff like that. They're all going to be integers. Your program has to stop when one of the three conditions happen. The first one is we run out of money. So that means you have to keep track of your balance. Okay? You start off with a certain balance, and every time you see the next number, you subtract it from your balance. When your balance gets to 0 or negative, you exit the program because you don't have any more money. That's the first condition. The second condition is we encounter end of file. Okay. Now, when we talk about scanf, we'll get to talk about this part. Or you have to get out of the program if you have any problem reading a number. In other words, you are expecting a number, but somebody typed ABC and pressed the enter key. ABC is not a number. So you have to exit the program because it's an erroneous condition. You cannot just let the program crash. You have to basically exit the program. Now, depending on which reason you use to exit the program, main has to now return different value because up to this point, main always returns 0, right? But in this case, I want main to return a value of 1 if you run out of money. I want you to return 0 in main if you encounter end of file because you have just processed everything. Or you can return negative 1 if the reason you're exiting is because you read something other than a number. Is that okay so far?
Yeah.
Okay, so I have several cases here for you guys to think about. So let's say this is one test case. Okay, so the first number is 76, which is your budget. Okay, this is the initial balance. So the first number you see after that is a 5. So you subtract 5 from 76, you get 71. 71 is greater than 0, so it's not time to exit yet. Then you read the next number, which is 10. You subtract 10 from 71, you get 61. 61 is greater than 0. It's not time to exit yet. You read in 20. You subtract 20 from 61. Yeah. So you subtract 20 from 61, which will give you 41, which is greater than 0. It's not time to exit yet. The next number is 100. You subtract 100 from 61. It is a negative value. It's time to exit the program. But you don't just exit the program. You have to make the main function return a value of 1 in this case. Here's the second test case. The second test case is starting off with 76 as the initial balance. But the first number after that is ABC, which is not a number. So in this case, you have to exit the program with a code of -1. The last test case I have here is basically an input file that only has 2 numbers, 76 and 26. So even though you still have money left at the end of this file, you still have to exit because in this case, you don't have any more lines to process. Yep.
Just to clarify, so when you say not a number, you mean not an integer? So even if it
Not
was
an
a
integer,
number,
correct.
It would still, okay.
Yep. If you put in something that has a decimal point, it will consider an error as well.
Okay.
Yep. All right. So the best way to test this program is to create test input files. Instead of typing in the input, it is best to make all those numbers or test cases in different files so you can feed the files or redirect those files into the input of this program. So the way to redirect the input into main, if you run it on the command line, is to do it like this. The less than symbol is for redirecting a file into the standard input file of a process, of a program. okay, which is the opposite of the greater than symbol, which is redirecting the output of a program into a file. This is redirecting the input of standard input file from a particular file. If you're doing this in GDB, then you can do this instead. The run command can also take on the same argument or the same options of a less than symbol and then a file to feed the file into the program. Let's go ahead and take a look at some of these cases. Okay, so what I'll do is I am going to give you a few test programs. Okay, and as I write the programs, I will explain what those components are. So I'll call this scanf1.cpp. The first thing you need to do is to include a header file. What this line does is it will go to a particular place, look for a file that is called stdio.h, which is a huge file, okay? But what this is going to do is to say, hey, take the content of that entire file and put it in as if it is here. Okay, and there's a lot of stuff there along all the stuff in stdio.h is the prototype of scanf. So this is how this particular program gets to know how to use scanf. Without this, it doesn't know how to use scanf. Okay, here's int main. I'll give it a local variable x, and here I would just do a return scanf. All right, this is enough just to get you started. The return, we know what it does. Okay, it returns a value. Scanf is a function call to the function called scanf. It takes on two arguments in this case. The first one is what we call a format string, and it is %d. Okay, it looks kind of weird, but there's a reason why it is %d. The other one is ampersand x. Okay, which is not just x by itself, but there's an ampersand before that. So I'll go ahead and explain these two arguments one by one. The first one is called a format string. It is basically saying, okay, scanf as a function is always reading from the standard input file, which is also known as file handle 0. Okay, remember, you only have one conveyor belt coming into your program, and then you have 3 going out. This is referring to the one that's coming in. But on top of reading, from that file, it is saying I'm expecting a decimal number. That's why we have a D, because it stands for decimal number. It's an integer. So the % is what we call an escape character, because you can put other stuff here too, but the % says, okay, %D as a combination means we are expecting a decimal number. Yep, go ahead.
If an integer is a decimal number, what's a real number?
There's no such thing as a real number. We have floating point numbers, which is kind of what.
But so if an integer is a decimal number, what's a floating point number for this string?
For the format string?
Yeah.
I think it's %f.
Okay.
Yep. Okay, so that explains the first part. Okay, and you have to put this part in double quotes. Okay, because it is a part of a string. Yep.
So that means some test cases are going to be like 10.5. Is that why you're doing decimal?
10.5 would fail because the decimal point, is not a valid part of an integer.
Well, then why is it called decimal if we're not going to be passing through?
Because it's base
decimals?
10.
So that
decimal
D
means base 10.
10? Oh,
Yep.
okay.
Deci is 10, so decimal is base 10 number. Okay, the second part takes a little bit more explanation. X is just my local variable x. The % symbol, the ampersand symbol in this case is quote unquote the address of. Okay, now this is the first time we see this. For the time being, what we'll do is we'll just say that if you have a variable that needs to get a value from scanf, you need the ampersand, okay, because you need to store something into the variable. It's kind of passing by reference, but it's not passing by reference. So for the time being, we just say that okay, that ampersand needs to be here because you're going to store something into X. Are we doing okay so far with that concept? Now, if I say scanf as a part of the return statement, it means scanf is going to give me a integer value, so I can return that integer value as the return value of main. So now the question is, what is scanf going to return? Okay, so we'll go ahead and test this program. I will start with compiling the program first. Scan F1, G++-O, scan F1, scan F1.O. All right, so we can now run the program. But before we do this, we'll do a man scanf, okay? Can anyone remind me what is main? What is man? What does it stand for?
Manual.
Manual, exactly, okay? It's a very useful feature. I don't have the manual page loaded into this machine, but that's okay. Because you can always look it up online. So you can say man scanf, and it will give you the same information, okay? Now, this is a typical, man page, which is kind of cryptic in many ways. But this is the prototype, okay? This is the prototype of scanf, which basically shows you, how to call it. We know that it returns an integer value because this is the return type of the function. We know that it has at least one argument, which is the format string. The ... means it can have any number of parameters after that, okay? So that's kind of mysterious. But what we want to do now is to focus on the return value. And you can read through all this stuff here, the conversion type, and you can see that D is matching an optionally signed decimal integer, so we know that part already. So we'll scroll all the way to return value. These functions, referring to vscanf, scanf, scanf itself, and so on, they return the number of input items successfully matched and assigned, which can be fewer than provided for, even 0 in the event of an early matching failure. The value EOF is returned if end of file is reached before either the first successful conversion or matching failure occurs. EOF is also returned if a read error occurs, and so on. Okay, so what does that mean? Let's go ahead and run the program first, and I'll show you what each particular case means. So we'll run the program, which is called scanf1. Yep.
So attendance going to be called over.
I forgot to print it out today, so we are all present today. Okay, so I'm running this program. I'm going to give it a number in this case. Okay, so I'll just give it, let's say 12. Press the enter key. The program doesn't do a single thing. Now the question is, how do I know what main is returning? Because we have never talked about that in this class, right? We have never talked about how do I know the return value of a particular program. This is how you do it. You say echo, $, and the question mark. And that tells you that it returned a value of 1. Why do you think scanf is returning a value of 1? Okay, let's think about it again. Scanf is going to return a value that is indicative of how many things it was able to parse. In this case, scanf was asked to read a base 10 integer. Did I give scanf a base 10 integer? I enter 12 and then press the enter key.
Yes,
is that a base 10 number?
It's a base 10 integer.
Okay, it can be interpreted as a base 10 integer, which is good enough for scanf, right?
Yeah.
Okay, that's good. Okay, so that's why it returned a value of 1, because it's telling me, yes, I got one thing. Well, I only asked it to read one thing, and it said it read that one thing, so it was successful. Is that okay?
Yeah.
So the next thing I'm going to do is to say, hey, let's try this again. This time we'll give it ABC, which cannot be interpreted as a base 10 number. Press the enter key.
One, right?
Well, it returned a 0. Because it's telling me, you asked me to read a base 10 number, I did not see one.
Okay.
So that's why it returned a 0, because it's telling me I could not read that thing. Okay, whatever you gave me was not an integer. That's what it's saying. Is that okay so far?
If you separated it with like letters, say put like 12A, 24.
Then it will read the first part correctly and it will still return a value of 1. Let's test it, okay? So what you're saying is we run the program again, we say 12 ABC, right? So in this
Add
case,
another number onto that though.
huh?
Let's see if there's two numbers on like both sides, you know?
But since I only ask it to read 1, it will only read up to 1, only the first one. But let's test this one, okay? In this case, it will still return a value of 1 because it will read the 1 and the 2 and say, and then by the time it gets to the lowercase a, then it will say, okay, I got one base 10 number, which is 1, 2, and it will still be successful. Okay, so we'll press the enter key and find out what it's going to do. It told me that it read one thing successfully. Okay. So what about end of file? Okay, this is the last one, which is really important. How do you indicate end of file? In other words, how do you specify I'm done entering, even though I have not entered a single thing? Okay. Do you guys remember? Control D. Okay. If a program is asking you to input something and you on an empty line you specify Control D, you are basically saying I got nothing to tell you. This is the end of the input. Okay, so I'm pressing Control D right now, which ends the execution of the program. Okay, because scanf is going to say, oh, the input file is empty. There's nothing on the conveyor belt. But the curious part is, what is it returning? In this case, well, it actually did not return 255. It's -1. Okay, but because we have only 8 bits as an unsigned number as the return value, that's why it is putting it up as 255. Yep.
How come if you in the homework end of file says 0 when you're showing us right now that end of file equals a -1, and when it gets an ABC that it returns
You will
0?
have to figure out the logic to make that conversion.
So you want us to convert it. So you want what it to returns.
I
we
want-
need to write the code in order to return
Exactly.
those things.
Yep.
Instead of
Yep,
automatically.
exactly. Because what this program is doing is returning really just what scanf is returning. So if you look at scanf1.cpp, I am just simply returning whatever value scanf is returning to me, which is not what your program is going to do. Yep.
We have multiple return statements. Are we going to need on the return line many different statements put with many semicolons?
Well,
to
that
make
part is up
multiple
to you.
return?
Okay, that part is up to you. You can use a variable to keep track of what value you're supposed to return. Then you can use a conditional statement to decide what value you actually want to return and put it into the variable. And then the last line of main, which is return, is going to use the value of that variable. So you can certainly do it that way. There's not a whole lot of restriction for this particular homework assignment. So when you read the homework assignment itself, it says, you can use any statement, any expression, any number of auto-local variables. You can define and call any function of your own. So you don't have a whole lot of restriction in this case.
When you say make a conditional statement in order to define what is returned, whether it's 0, 1, or -1, you're talking about only using a return outside of that conditional statement? Or is the return within the conditional statement?
You don't want to do a return within the conditional statement.
Okay.
Yep. Well, you
then how
can,
do
but
you-
it's not a good
Then
idea.
how are we going to have a conditional pass what it... I understand. I get it.
Yep. You have a conditional statement to determine the value of the variable that controls the actual return value of main. All right. So we didn't have enough time to talk about scanf completely. So what you want to do is to read my notes on scanf so that on Monday you will have some idea of what scanf is, how to make use of it in general, and then I'll give you the actual homework assignment on Monday. I'll give you 1 week to work on it from Monday. Yep.
Oh, no, just ask
Okay.
class.
Alrighty. I'll see you guys on Monday. Have a nice weekend.
At the very top of the assignment where you said that the only function using scanf and no other functions, that means no other function from C, right? Just because otherwise there's kind of a logical contradiction.
Right. I just don't want you guys to explore. Oh, can I do this using this and that? No. Just use scanf. That's all. Yep.
Has the inputs for the grades or the attendance for Monday